Okay, welcome to lesson 2.4 notes on multiplying rational numbers. Today we're going to be practicing the same skill we've been doing with our integers on multiplying rational numbers. Remember, the same sign means we're going to have a positive answer, and different sign means we're going to have a negative answer. And we can use our little triangle symbol here to help us remember that. So looking at example 1a, we have find negative 2.5 times 3.6. Well, we have a negative times a positive. So if I have a negative times a positive, my answer will be negative. And I write that down so that I'll remember the sign after I do my regular decimal multiplication. So 2.5 times 3.6. Remember, we start with a 6 over here. 6 times 5 is 30. Carry the 3. 6 times 2 is 12. 13, 14, 15. And then we put a 0 for place value, and we do 3 times 5 is 15. Carry the 1. 3 times 2 is 6, plus the 1 is 7. And then finally, we add up all the digits. So we have 0, 10, 7, 8, 9. And then we had 2 decimal places in our math question, which means we should have 2 decimal places in our math answer, which gives us an answer of 9. But remembering our negative, our answer to 1a is negative 9. Okay, over on to B, we're going to use rational numbers in fraction form. We have a negative times a negative. That's going to give us a positive answer. And then we're going to use our 1/3 times. But since this is a mixed fraction, we're going to change it to an improper fraction. So we have 4 times 2 is 8, plus 3 is 9, 10, 11, 11 fourths. And then we look to see if we have any common factors in the diagonals that we can reduce. Here we can't because 4 and 1 are already simplified, and so is 3 and 11. So we're just going to multiply across. 11 times 1 is 11, and 3 times 4 is 12. And again, checking our answer is positive. And so we have 11 twelfths. We can't simplify that. All right, you can pause this video and try questions 1 through 4, and then come right back to check your answers with me. Okay, let's take a look at question number 1. We have a negative times a positive gives us a negative answer. We have 5.1 times 1.8. We're going to start with the 8 here. 8 times 1 is 8, and 8 times 5 is 40. And then bringing a 0 for place value here. 1 times 1 is 1, and 1 times 5 is 5. And then adding our digits. And then 1, 2, 1, 2. So our answer here is negative 9.18. Remembering that negative sign. Okay, for number 2, we have a negative times a negative. That's going to give us a positive answer. We have 6.3 times 0.6. 6 times 3 is 18. Carry the 1. 6 times 6 is 36, plus the 1 is 37. If we did put a 0 here and multiply, we're just going to have a row of zeros. So we're actually done with this problem. 1, 2 for our decimal places. 1, 2. 3.78, and our answer is positive, so 3.78 for question number 2. Okay, number 3, we have a negative times a negative. That's a positive answer. We have 4/5 times 2/3. Again, 2 and 5 don't have common factors. Neither do 4 and 3, so we're going to multiply across. 4 times 2 is 8, and 5 times 3 is 15, and our answer is positive 8/15. Okay, number 4, we have 2 mixed fractions, so we know we're going to have to change them to improper. And we have a positive times a negative. That's going to give us a negative answer. So 4 times 2 is 8, plus the 1 is 9. We have 9 halves times 2 times 3 here is 6, plus 1 is 7/3. And we do have a 9 and 3, which can both be divided by 3. So 9 divided by 3 is 3, and 3 divided by 3 is 1. Multiplying across, we have 21 halves. So our answer is negative 21 halves. And then to simplify that, 2 goes into 21 10 times with 1 remainder. So our final answer is negative 10 and 1/2. Remember to bring that negative sign over. Okay, sometimes we use properties to multiply rational numbers. Remember that multiplication is commutative. Order doesn't matter with multiplying, just like it wouldn't matter with adding. So we have a series of fractions and numbers to multiply here. I'm going to start with this parenthesis here. The first one, we have negative 1/7 times 4/5. So we know here we're going to have a negative answer. 1 times 4 is 4, and 7 times 5 is 35. And we're going to make that fraction negative. We're going to multiply that to negative 7, and if it's not a fraction, you can always just write it over a 1, times negative 1/2. So looking at this, I can choose to go in further out diagonals here to cross out any common factors. So 4 and 2 can both be divided by 2. And 7 and 35 can both be divided by 7. And so now my numbers multiplying across is negative 1 times negative 1 is positive 1, times a negative 1 is going to give me a negative 1. And then 5 times 1 is 5, times 1 is still 5. So our answer here is negative 1/5. Okay, find the product, write fractions in simplest form. For number 5, we notice that we have a fraction, a mixed number, and a fraction. So we're going to rewrite this as our fraction here, but actually I'm going to leave it like this, and I'll show you why in just a second. I was going to change this to an improper fraction, but I notice here that I have a 3 and a 3, which can be canceled out by dividing by 3, so that becomes 1 and 1, and 2 can both be divided by 2 for 1 and 1, and then all I really have is a negative 1, because negative 1 times 1 is negative 1, and 1 times 1 is 1. I really have a negative 1 over 1 times 7 and 7/8. Well, that's just like 1 times it, but negative. So my answer is just negative 7 and 7/8 here. Okay, looking at number 6, I have a couple decimals and a couple numbers here. And I have a negative times a positive. That's going to give me a negative number times a positive is still negative, times a negative is going to be positive. I also notice that this is 1/10, and 1/10 of 100 is just 10. So I'm going to write negative 7.02 times 10. I took care of these two first using the associative property, and then times negative 10. So again, order doesn't matter for multiplying. You can choose which ones you want to multiply first. And now I'm going to do negative 7.02. I know 10 times 10 is 100. Since I have different signs here, that's going to be negative 100. Okay, a negative times a negative is going to give me a positive answer. And if I'm doing 100 times a number, that means I can move it over 2 decimal places for the 2 zeros. So my answer is 702. Okay, let's turn it over to the other side where we have a couple word problems using rational numbers. Example number 3, modeling real life. We have a school record for the 40-meter dash is 15.24 seconds. Predict the school record after 15 years when the school record decreases by about 0.06 seconds per year. Okay, so that's our unit rate per year of 6 seconds, and that's going to happen for 15 years. So our math problem here is 0.06 times 15 to see our total decrease in seconds. So we're going to multiply. We have 5 times 6 is 30, carry the 3. 5 times 0 is 0 plus the 3. We're going to bring the 3 down. And then 5 times 0 is 0. Okay, we're going to place a 0 here for this row and do 1 times 6 is 6, 1 times 0 is 0, 1 times 0 is 0. Adding up our digits, we have 1, 2 decimal places in our math question, so we're going to have 1, 2 decimal places in our math answer. So we are shaving off about 0.90 seconds per year in total for the 15 years, because that was the 0.6 per year. So it's 0.9 for the 15 years. And we're going to have to subtract that from what we had, because a decrease means obviously it's getting faster, which means less time. So when we subtract, we line up our decimal. 4 minus 0 is 4. 2 minus 9, we're going to have to borrow from the 5 here for 12 minus 9, which is going to give us 3. And then we have 14 minus nothing here, so that's 14. So 14.34 seconds is the predicted new time in 15 years. Okay, looking at number 7, we have a swimmer's best time in an event is 53.87 seconds. On average, his best time decreases by 0.28 seconds each of the next 5 times he swims the event. Does he accomplish his goal of swimming his event in less than 52.5 seconds? So that's the question we're answering. So we're going to do 0.28 times the next 5 swims. So we have 5 times 8 is 40, carry the 4. 5 times 2 is 10, plus 4 is 14. Carry the 1, and then we have 5 times 0 is 0, plus the 1 is 1. And 2 decimal places in our math question for 2 decimal places. Okay, so he's going to shave off 1.4 seconds. So his time is 53.87 minus the 1.40. We have 52.47. The time to beat was 52.5. So our answer is yes. The swimmer will accomplish his goal.